So in general, that's actually a good segue to one of the last topics that I wanted to cover about cloud control, and especially along those lines that you want to enable your end users, your developers to self-service themselves, to be able to spin up their own VMs whenever they need to and take advantage of your shared infrastructure. On one hand, you're dealing with a larger scale. You're dealing with a more dynamic infrastructure, and you're no longer just dealing with VMs that are already running in your environment, but VMs that are popping up and disappearing, and not even talking about containers, but at the speed of hours or days as opposed to weeks or months previously. So in the context of the question that was asked earlier about provisioning, either with VCAC or with OpenStack or with CloudForms, we are enabling these cloud management tools to take advantage of VMTurbo's intelligent decisions by plugging into both the decisions on where do you start your VM initially, and then of course once it gets provisioned, it will continue to control that. But we do that in a way that we keep the existing user experience. So for example, in the case of OpenStack, you would still go through either the Horizon dashboard or the OpenStack API, and it would end up in the same Nova scheduler, but the Nova scheduler, instead of trying to parse some predefined rules, would talk to VMTurbo and get a decision on where to deploy the exact number of configuration of VMs that you're asking for. VMTurbo comes with very specific actions, telling the scheduler to put this on this Cinder service or put this on this Nova compute node, and it would actually end up provisioning it seamless to the user, but intelligently those VMs by taking advantage, of course, instrumentation that's already built into OpenStack with Ceilometer, plus the additional instrumentation that we are contributing to OpenStack. Pretty much all of our contributions up until now has been accepted in the Kilo release, so they're part of the downstream Kilo distribution from Red Hat and other vendors as well. And the way we want to do this, not just to provide open source contribution to the additional instrumentation that we are providing, such as in Ceilometer, but all of this scheduler code is actually published as open source. And since our REST API is also publicly documented, you could modify it and change it and do whatever you want. You write your own version of it. We did the same thing with our CloudForms integration. All of the CloudForms integration with VMTurbo is also in open source, available on our GitHub. And one of the cool things you asked, what does it take to integrate with another homegrown provisioning tool? We not only want to provide all of these good pieces of code open source, we actually have a growing community around this. So some of the things that Eric mentioned earlier, this company that did a Scorch integration as part of their provisioning workflow actually contributed a series of blog posts on our Green Circle community along with the source code of how to do this. So if someone wants to do this on their own, they could just take their code, replicate it, preferably create another blog post on our site. So while we have the ability to help any one of our customers or prospects to use our professional services, what I think is actually even better and more productive is to continue to build on our community and have them help each other to create better integrations or better ways of using VMTurbo as a platform beyond what we provide out of the box.
We actually have a contributor right here in the room that we happen to know. So Amy is a contributor to stuff on the Green Circle, and thank you for that. That's an important part of what we try and do is promote open communities. Granted, people always say it's a Green Circle, it's VMTurbo, but there's a surprising amount of general open content in there, and what's good is that's the kind of thing like we talk about, using REST APIs, enabling that, and once it's done once, then it's easy to go back, find it, and share that out. And of course, we're all here because we made a career out of sharing our experiences and growing a community. So, we're really proud. I'm particularly proud we're doing a lot of other ways through Green Circle with live video content and lots of other cool interactions that are going on. And it's just neat to watch this whole thing grow. But from a technology perspective, it's especially exciting because our customers are showing us how to use our product in ways that sometimes we haven't even thought we wanted to go. And all of a sudden, that could drive sort of the next step. In the same way that other companies say, if you've got an idea, if you've got a concept that you want to bring into VMTurbo, we have a way to drop that idea into the green circle and help to kind of drive things that we do. If you've got a use case, like that's important. Everything when we get asked about what's your roadmap, well, it's an easy answer. What's your roadmap? Like what's your next step that you need to work towards, and we can probably help you there. We may already be on the road. We talked about some announcements that are coming and some that have, we release quarterly. It's very rapid, and that's because all the great interaction and feedback that comes from community and customers and prospects.
Yes, you get feedback right away, and it's nice with the custom reports. Someone probably already wrote it for you, so yeah, I go there a lot.
And I always need the fellow who wrote our this 3 series REST API. I'm like, this is awesome. This just saved me a ton of time. I was looking to do some stuff with Puppet, and I was like, this added a whole new savings in time for me to do that and do a few other things using that code that's out there. So it's very cool.
Back to OpenStack for a second. The reason I talk about OpenStack is because on one hand I think it's a very exciting and a pretty quickly growing and maturing option for running your own private cloud. What we want to do is not only to make it as enterprise ready as any one of your existing private cloud implementations, but we actually have the chance of making it better. So while initially we said that we are going to contribute additional metrics, we are going to provide a semantically consistent VMTurbo integration. So if you had, a disaster recovery anti-affinity policy defined in OpenStack that was used through the Nova Scheduler filter driver to drive the placement of VMs in the infrastructure. Even though we replaced the driver behind it, we are providing the exact same functionality. We actually have, I think, a couple of examples of this, or you've got a particular licensing requirement. We're taking the exact same description of how flavor specs should match to host aggregates, and within those constraints we find the best placement for your VMs, but we actually enable additional functionality that you couldn't really do in for example, in VMware. So one of which is to provide differentiated service offerings, and I think I briefly alluded to this, is to be able to say that some of the VMs are going to be really important, some other VMs are not so important, and I want to intelligently manage how I allocate those resources. For example, how do I take advantage of KVM CPU shares differentiation, but drive the placement of those VMs so a whole bunch of gold VMs don't all end up in the same place because the CPU shares will not help me. But how do I mix the right number of bronze VMs and the right number of gold VMs across my whole estate, both in terms of the initial as well as in terms of the ongoing placement, so that the shares will assure that the gold VMs will always get more resources, but the bronze VM will get the resources when they don't need to. Or another one that I kind of alluded to is licensing. Where you want your production Windows VMs to run on a certain group of hosts, and your production Linux or non-production Linux run someplace else. One of the things that we saw that was interesting, where people, even though it's a nice private cloud, you still want to do maintenance on the infrastructure. So we introduced the ability to use our REST API to tell VMTurbo that we want to do maintenance on a particular host. So it actually finds the best place for, not just evacuates the host, but it actually finds the best place for all the other VMs that are running on that host, and effectively moves them, so that we could do maintenance and of course take the host out of maintenance, which wasn't natively available in OpenStack. But it's a nice additional feature. Okay, so that, and of course, OpenStack was the first place where we provided share nothing migration. We are now actually enabling the same functionality across other hypervisors as well. It's just that a number of the customers that are running VMTurbo with OpenStack are running on local storage. So when we need to find the best place for a VM or move a VM, we need to move the compute along with the storage. So we do that natively. We actually automatically figure out when we need to move the storage, and we do a block migrate instead of a live migrate. And of course, we find the best Cinder providers. So not only find the best compute, but if you're using a Cinder provider, what is the best Cinder backend for your volumes to sit on?
One more question. You went from VMs to applications for monitoring. You added the cloud, or you're looking at the cloud component. Are you looking, or are you going to look at something called the service bus in the cloud?
So very good point. So the OpenStack slide that I had were very infrastructure as a service focused, which is practically the same type of thing that you would do on your other virtual infrastructure, building your private cloud. What we started to do with the containers is to start to climb up in the stack, and our container control capabilities were released last year as GA. What we're doing now is we're integrating with the platform, CloudOS, and the platform layers, such as Kubernetes or Mesos, as well as best providers like Cloud Foundry and OpenShift, where we want to provide this intelligent capability of finding the best way to scale your application based on the application service level that we described earlier, but with the understanding of how to best use the resources within your infrastructure, not just VMs, but containers.
Would that mean that I would be able to define an SLA on my service bus tenants and prioritize them on that level?
So yes, but what do you mean by your service bus in this case, just to make sure that we're talking about the same thing?
It's a presentation layer to the outside, to the users of my applications who come in through my private, hybrid, whatever cloud.
So actually, some of this we do this already. We are already. I mean, I don't know if that's the one example. Is that we already have for years actually integrations with a load balancer. So if we look at applications behind the load balancer, as we differentiate between one application and another, we can not only spin up additional instances, but we can modify the load balancer configuration to scale them out. I'm pretty sure that we could do the same thing for other ways of exposing those services to the end users as well, or orchestrate around them.
But making provision decisions around horizontally scaling applications is the core of what we do. Now, the specific way that you've defined that virtual application in your particular infrastructure or your particular cloud OS, these are the specific things that we continue to expand. We do it natively, we do it in conjunction, we do it very well in a Red Hat environment. You know, we're looking at Cloud Foundry, how do we understand virtual applications better inside of the Cloud Foundry environment, for example.
Yeah, the advantage is that everything ultimately, again, feeds back to the overall picture, and that's what's important. Of course, the verbiage we use, we talk about, vMotions when we talk about Cinder, and that's just because there's a familiarity with it. But of course, it's multiple hypervisors, multiple, vendors, multiple different applications. So it's, a lot of us came from VMware backgrounds, and we don't have Jeff here to represent for the Hyper-V, so agnostic computing. I know you're out there. I know you're out there. SIPs. And he should be happy. We said SMB3, so that's what's really interesting. And OpenStack, obviously, I've been around it for a while, and we've seen the growth in acceptance. And we did a survey recently, which we had a huge, response. We were hoping to get like 400 or 500 folks that would respond. We got 1,284. I know that's a funny number. It's easy to remember when it's an odd number like that. So, and out of that, we had a really, really high uptake in people that are looking at OpenStack. And the reason was because, as Bob talked about before, we're moving to that next layer of creating service capabilities for our consumers. And, multi-tenant's a way to go, being able to be developer friendly with APIs. That's where we're looking at other integration with things like Chef, Puppet, and other application lifecycle management tools, because we can sit in the middle of that. So when they want to make a request to create virtual machines, virtual environments, rather than doing it directly in through a vSphere API or an OpenStack API, They can make those requests through our REST API. We make those decisions for it and actively place it in real time, on initial placement, and then continuously control it beyond that. And that's one area in OpenStack that's missing. Initially it's a round robin scheduler. So here you go. Even when you evacuate a host in VMware or in Hyper-V, it just blasts all of the resources out to other hosts that are available
that look like they have capacity.
Right, and
but
then
it's not a
and then it thinks about
complicated calculation.
Now I've got a problem because now all the other sort of native capabilities have to kick in, saying, did we just overload that? Now, of course.
Yeah. DRS is very RAM centric, like is there enough RAM to hold this thing, it doesn't take into account any of what you guys compute,
And the good thing is we've got multi-platform environments. Now I'm one of those oddities that I have multiple platforms running, and then this way you only have to have one single view of the overall data center, and as we grow and adopt more tools, OpenStack on top of VMware. Absolutely, we get the best of both worlds. You can use our APIs in order to create and move and just deploy workloads, and that we have all the underlying VMware instrumentation that we already gather as it is.
Having said that, most of our customers are running OpenStack on KVM.
KVM is big.
That's the whole point, is get away from VMware, and
I think so.
yeah, well, and more people, especially now that there are options for. Why are people staying on VMware? For certain features. Live migration is a fairly new thing in the OpenStack world, and it's been around for 12 years or 10 years or so in VMware. Like my environments could not live without it. And but adding that capability, and then you guys being able to manage it kind of in don't take this the wrong way, I'm going to say, in a VMware-esque sort of way. You guys are doing more in that regard, but the being able to bring those capabilities to those environments by adding your product on top of it, that's cool.
How about enterprise ready?
That's right. Yeah, that's the real key, right? Is that enterprise ready tag that we want to put on things, and that's exactly it.
Yeah.
The original idea of cloud was the pets versus cattle concept, and it was this thought that it's going to be just like that. Just like in 15 years ago, if you bought new EMC hardware, you got rid of your old IBM hardware. But now we run IBM, Pure, EMC,
nothing ever seems to go
Nimble.
away.
I run it all in the same data center, and I let the workload choose where it needs to be. Or unfortunately, people are letting sysadmins choose where they think the workload should be, and that's why VMTurbo is particularly important, because we will have that full stack view across all of those platforms, hardware and software. And then we will place the workloads based on where they really need to be based on application.
The thing about DRS was the most powerful thing. Let the machines do the deciding, because I'm not watching them all the time.
Right.
So.
Yeah, we love to think that we're particularly good at outthinking the machine. That's great, but I go home at 6, hopefully. And at 6:01, things
you've
can
never
happen.
watched Terminator,
So just maybe to illustrate some of this. So for example, this happens to be a OpenStack availability zone with 4 KVM nodes, and it looks very much the same like a Hyper-V data center on top of this. In fact, it very much looks the same as a Amazon zone, and this happens to be an Azure zone on top of this. So you get not only a consistent view and a multi-tenant view of all of your infrastructure, you actually get a complete control system for all of your clouds, and we are driving the same sort of actions. We are automating and executing them by calling the appropriate API in each one of these cases. In this case, finding a better place for a VM to run, like migrating it from one KVM server to the other. And if I drill into other VMs, where was I? Other VMs running in an OpenStack, you basically get the same information. This is not a super busy infrastructure, so but you get the same way of managing all of the infrastructure. on OpenStack, as well as, for example, this happens to be, we're actually managing our public-facing web service that runs on Amazon using VMTurbo.
That's how much we trust it.
So basically, you get the same control capability with the same ability to view the same information across all of your public-private cloud, OpenStack, as well as other virtual infrastructure.
And you know why I'm impressed? You didn't say single pane of glass.
There we go. And Alistair brought up a good point before we talked about issuing a PO, and that's an important thing is, as a capacity planner role, you've got a need to think ahead of where your infrastructure is, and that's one of the great capabilities. This all this real-time information that's going in and driving active decisions and creating those actions also tells us what the real utilization is of your infrastructure. So if you think that I'm going to deploy I have to put in 100 virtual desktops and I've already got 20, you just take 5 times what your current utilization is. Not necessarily. You may have estimated what your first deployment was, but we actually are able to use capacity planning as part of VMTurbo to take a look at your real infrastructure. You can do projections based on if I'm going to grow by 100 virtual machines, if I'm going to grow by X number of terabytes of storage, and use capacity planning to actually tell you what hardware, what resources you're going to need, and what the impact is going to be on other resources. If you grow by 100 VMs and we profile it against a current one, that particular VM that's an application that you're going to need a lot of may be CPU heavy. But if you looked at it compared to 10 other VMs, they may look like they're the same, but in actuality, we've watched this thing in real time continuously since its inception, and we've seen that, no, it's going to be 80% CPU. Therefore, that's going to change the decision you make when you look at projecting what you need to buy down the road.
Cool.
So I think what's important is a single unified control system.
There we go.
Not, for your whole stack, from applications down across your different clouds. That I think.
The other is we stay away from single unified control because it starts to spell suck. But
but that's why I'm not in marketing.
Single view of control, SVC. That's and ultimately again
virtualization.
It's the quality of service is we've accepted that we trust network quality of service. We trust quality of service in different storage platforms that are out there today. That's their whole pitch is that we can define quality of service based on a number of metrics available to that platform. Then just imagine if you could take that again, extend it from bottom of stack to application layer, and that's where we're doing really, really cool stuff.
Cool. Yeah, that's a big hot frontier there too. Storage vendors finally figuring out that QoS needs to be baked in all the way through.
Yep. And we actually working with a couple of those, and I think what's really interesting is that they build in the ability to define QoS, but they leave it up to the users to figure out how to use and configure it, which is great because once we sit down with them, it's like, you could actually map your application service level and transaction performance and drive the way you use my QoS resources. Perfect, marriage, I guess. And so we're having that conversation with a number of the vendors.
What if I have an application which is custom, like built in-house, or what are the way you can detect performance issues?
Right. So as Charles mentioned, we are not in the business of finding better ways to monitor the infrastructure. And while we provide out-of-the-box ability to gather metrics and to drive actions for a number of the most common applications like Java application servers or database platforms, we actually expose a number of these capabilities through the REST API. And we actually offer a full Java SDK that allows you to not only instrument but to control your applications by taking advantage of our platform. So you could feed in your own metrics, you could drive your own control actions by using our software, by integrating through the Java SDK. The Java SDK is on our GitHub page with examples on how to, several examples on how to use it.
Everything from the VM down is application agnostic. Above the VM, if you're deployed on a platform that we support, we'll gather those metrics natively. If you're deployed on some other platform, then the SDK is available for you to get those metrics into our system.
Now, I saw you guys mention or talk about Java a lot, but earlier I also saw a slide for .NET because Microsoft is still big in a lot of
Yep.
smaller and medium-sized shops.
Yep. So we've got full WMI instrumentation, so we can discover everything about the Windows applications through WMI. We're building, actually, in the release we're about to release, support for additional Microsoft packaged applications as well. So Microsoft applications, just like Java applications, already supported, in this case through WMI instead of through JMX.
Nice.
And Linux-based applications through SNMP, if you're not deployed on Java on Linux.
And most of the new applications and new platforms, like storage, obviously is a big thing. Everybody's becoming API friendly, and they're providing that instrumentation about performance inside their platforms via their API. So that's just like happiness for us as we look at additional partnerships and better ways to drive that control. Everybody's winding down. Excellent. So how is... Now, as far as VMTurbo, who's actually a VMTurbo user here today, other than Amy? I know she's definitely an active user. Who's actually had production experience on VMTurbo? Well, we're going to have to fix that. So you all come to talk to me, and we will. We can get folks set up with NFRs and give you access to it in order for you to test drive what it is, because it's important. When we look at the interface, you're going to get a brief view of it here, but it's not quite what it's going to be like to actually see it in real life in real time.
Well, to run it for a while too, to be able to see stuff.
That's just it.
Monitoring tools and stuff like that are pretty hard to evaluate when you've got 30 days of trial or something like that.
Yeah, we're actually very lucky that in the way that we can test things out is we test out on your infrastructure, right? We deploy quickly. It's simply deploying our control instance deploys as a virtual appliance, and in certain platforms it's a QCOW image for on KVM, and within 15 minutes you're starting to see detail come in. But again, like the more we watch, the more we see, the more we
want to see the cycles, the end of month stuff that happens in certain systems. And I work for a university, the beginning of the school year, holy Christ, that sort of thing. So
when coming out of, I worked in financial services, and we had a website that we thought, and this was the human trying to outthink the machine, right? We knew that we released a particular set of data on a particular day. It was always around the 7th or 8th of the month, and we knew that was the important information because it was delivering statements to talk about what's in people's portfolio, and that was considered to be the all hands on deck, 24/7. Everybody's on call. We've got to be ready because the website can't go down during this time. And ironically, when we actually looked at Google Analytics, we realized that actually on the 29th of the month was when everybody went in, because no one really cared about the PDF version of their portfolio, because in the 7 days since the end of the month, a lot could have happened. The market could have tanked up, down, whatever it would be. And in fact, we had tried to predict what that usage pattern was, but in practice and in reality, that wasn't the case. And that's the important thing, why when we think, I need an 8 CPU machine with 64 gigs RAM, quite often we say, okay, that's fine, have a run at it. And then we will set it to be automated for resize, and then they'll find that their application runs just fine, transaction per second operate just as expected, latency is as needed, and then we just may shrink it down along the way without telling them.
Yeah. But you have the data to support that. It's not
Right.
It's not a I said, he said, she said sort of thing. It's not two people arguing. There are actual facts there. Not that makes a difference.
All of the content is held in there too, so it's not like we're blindly, creating these actions and enacting them, and then having no way to go back and look at it. There's a full trail of who made that, and when it happens, which is good because then you can take a look. And as we see that pattern, we get asked all the time about peaks. What if I know on the 30th of the month it's going to be particularly busy? Should I size up for that? Well, let's let it figure itself out. And quite often, again, we try and outthink the machine, but the machine's pretty darn good at figuring this thing out. So.
And that's also nice too, having all that analytics for packaged software vendors who say, no, we really need 8 CPUs and 64 gig of RAM. Mm-hmm. And if you don't have it, we won't support it. Well, guess what? We watched it, and you're only using 2 CPU worth and 16 gig of RAM. So why don't you, here's all our data, change your support.
And
That
then
doesn't work. But
the classic one that we that's right. Yeah.
Okay.
Or just run it
pump it
anyway.
back up.
And we talked about licensing, and that was a big one that comes up all the time, especially among our Twitter friends. And this one's for Paul Meehan and all the Oracle folks. That that was one of the reasons why we have the ability to create affinity to co-locate certain machines onto certain hosts. Microsoft SQL, Oracle SQL, because there's licensing by physical.
Well, even
CPU.
Windows Data Center licenses and stuff like that.
Right, yeah.
Red Hat licenses, that sort of thing. You license the underlying host, but now I'm supposed to keep everything pinned. Yeah.
And so that goes in as part of the policy for us. We try not to do those because it does create a manual constraint, which creates restrictions if an action needs to be taken down the road. But at least it'll highlight, and we can also tell you that based on this constraint that we've applied, you're running into a problem. So it's not like we're ignoring that once that policy's gone in, but we continuously will take that policy into account when creating actions. And then we can tell you that, hey, it would be helpful if we wouldn't keep doing this over here.
So you mentioned though sort of what if planning stuff, does that take into account licensing and all that stuff then as well? Okay.
So basically we represent all of the constraints as part of our market model, the same way as performance constraints get priced and sold and bought by the VMs. Licenses, as we feed that information, become other commodities, and they're being shopped for and priced the same way as everything else. And because when you run a what-if scenario, it runs the exact same copy of the exact same market using the exact same analytics engine. All of the what-if scenarios will answer all the performance and licensing or business policy questions at the same time.
I get some clarification on some of the network stuff you were talking about earlier. One of those slides, when you were talking about network control and flow control, you showed concerns about latency in then public versus private cloud. That's obvious. That makes sense. You don't want to split your workloads and have to have them communicate across a high latency environment like that. Were you also concerned about that within a data center, like between pods?
So that's a very interesting question. I think that if you looked at a three-tier Cisco architecture, they probably should be concerned about it. If you look at a spine leaf architecture, then probably less so.
Right.
So you're absolutely right. I think that I talked to a bunch of customers and I talked to a bunch of vendors, and the vendors would say that, well, spine leaf, fully provisioned, just buy as many links, as many switches that you have, and that's nice, and I understand why they say that. When I talk to customers, they're like, well, in reality, I don't do 1 to 16. I do 1 to 4 over subscription, which actually is still probably fine. I think what's interesting is but they do it at higher speeds. I think what's interesting at higher speeds is buffering. And preventing basically the impact of microbursts. So it's not so much as you'll introduce latency because of steady traffic, because of the limited bandwidth, but how do you handle applications that talk a lot and infrastructure that ends up sitting on a relatively bursty port.
What, over buffering, where the buffers are simply too big?
Well, okay, so that's an interesting conversation on how big your buffer should be. There's a camp of vendors out there that think that big buffers are great because you can better handle stuff. There's another camp who would say that it doesn't matter because, anyway, point is that I think that there is some level of oversubscription, and I think that with any level of oversubscription, you have the chance of having some level of buffering. And I think that what we can do is to not just minimize the traffic that goes through your spine, which may not be that as much a problem, but find the best place to run your applications by understanding how bursty your traffic is, how much you're utilizing those buffers, whatever those buffers are, and try to avoid co-locating applications on that communicate through the same ports that seem to have relatively high buffer utilization.
So that leads into another question, which is, you mentioned Arista, and I think on the slide I saw Cisco on some level that you can integrate with the physical underlying fabric. Who else is in that mix? And by Arista, I think that means EOS integration through APIs.
Yes.
With Cisco, I don't know what exactly that means.
So I don't know if I have this on the slides. Actually, maybe I did. But in any case, from a perspective of the underlying physical infrastructure connectivity and things like buffer utilization, that is currently GA for Arista. We have not yet released that for other vendors. We actually have a couple of other hardware switch vendors reaching out to us that like, oh, we've seen what you've done with Arista. Can you please do this with us as well? Another one starts with J. and we're having conversations with Cisco as well. We haven't released any of those yet. Arista is now GA.
And I'm assuming that hardware integration is customer driven. Whatever they're running in their data centers that they want you to integrate with, that's who you're going after.
Exactly.